Fine, so let's get started. Okay, so today's topic is exceptions, and okay, so let's start with some simple code. Okay, uh, okay, maybe I think there's something which we have done earlier. Okay, so yeah, what would happen when if in a main method or somewhere, right? If we try to execute something like this, int a equals 75, int b equals 0, and int c equals a divided by b. Okay, and then we are saying, okay, let's print the value of c. Okay, fine. I think you all know what happens then. Yeah, if we have this, if we execute this code, yeah, especially at this line, yeah, what happens? So what would happen when we try to do this? Yeah. Yeah, it will be giving error at runtime, right? Okay. Fine. Okay, so this is one thing we know about, right? Now let's see what happens if we in our test account class, right? We try something like this. We have account, and we have this code already, something like this. AC1 equals new, and we said, oh, we want to create a new current account. Okay, and maybe I use constructor with only 2 parameters, and okay, something like this, and we create this object, and then we'll say, okay, AC1 dot deposit. Yeah, what would happen? Yeah, if we tried this thing, what would happen? We AC1 dot deposit, and we say, oh, I want to deposit minus 50,000. It will result in debit of the money. Yeah, okay. So, fine. Someone is expecting that with deposit, my balance will be getting incremented, but what happens here? Oh, it's not incremented, but it's getting decremented. Okay, and that's not actually a correct thing, right? Okay. So yeah, what should have happened? What do you think should have happened? See, what happened here? We have a and b, two values, right? And when we do a division, okay, it's an integer division, and in integer division, if the second one, right, the second operand is a 0, fine, then I can't give you an integer value with this. Okay, I don't have an int which can result in this, right? Okay, so that's what the system says. Okay, I can't do this. I can't see what is a divided by b. What's the type of expression? If I look at this expression, a is int, b is int. What is this expression? The expression is an int type, right? It is expected that this will be giving me an int value. But do we have an int value which can be given if the second operand is a 0? No, there is no valid int here. So what do I give back? What should this operation result in? So I can't give you a result. That is the idea. If I can't give you a result, I'll give you an error indication. Okay, fine. Here, what do we want? Should I go ahead with this operation of deposit? Can I do this? Right? So what should have happened? Similar to what the divide operator does, our deposit method should also be doing a similar thing. You give me a negative value, no, then you can't have a successful deposit. A deposit cannot be successful if you are giving me a negative value. Right? So this should also have resulted in a runtime error. See, it's not the fault of the account class. Is it a fault of the account class? Someone passing negative value to the deposit, anyone may attempt whatever he wants, right? And it's not the fault of the account class. But here, yes, if someone, if the account class is allowing a negative deposit, it's a fault of the account class, right? But what one will do, yes, one can do any kind of parameter. He might give anything, right? Because our account class says, see, what does the account class say? If you look at the deposit method, how is it written? Public void deposit, okay, and takes long amount as a parameter. So when it says long, oh, there's no way to indicate that only positive values must be given. Okay, so from the point of view of the one who has written the deposit method, it would just say, okay, fine, I allow a long value, and then if any long value is allowed, what should be done here? First thing I should do is a check, right? I can't be having a negative value. If there is a negative value, then I can't be doing a deposit here. I have to fail it. Okay, the deposit must fail. Okay, that's what we want, right? Here, this is our expectation now. Fine. The new thing which we want to do is, yes, we want the deposit to fail if someone gives a negative value. Okay, so to understand all this, right, let's go back to understanding first thing. First thing which we will now have to try to understand is, okay, what we mentioned yesterday, how execution happens in Java, right? We need to know about the runtime stack and the heap. Okay, and so let's look at that aspect first, and then we'll come back to how we can manage to have an error if a negative value is coming. Yeah, how do you give an error? What do you think is the solution here? If someone says deposit, yeah, you may have a check, right? So for example, you'll say, okay, if amount is less than 0, or you can know that amount is less than 0, but then what can you do about it? Is it just that, okay, I won't do anything? I'll not update the balance? That is giving a wrong signal to the one who has invoked. It's giving a signal that yes, your deposit has been, you have completed the deposit successfully, which is not like what happens when someone tries a division. Division could have said, okay, fine, I won't do anything. Okay, fine. So the idea is, yes, any what are methods? They are just operations, right? They're similar to the operators. We can think of it that way. Okay, fine. Or if you want to have a, just consider that there is a class called math, okay, and it has a public method, returns int, name of the method is divide, and it takes two parameters, a and b. Okay, okay. So what would be done first? It has to check if b is equal to 0. I can't give you an int value. Fine, I can't give you an int value. Fine, you can't be writing a return here, right? Can we have a return? And in other cases, yes, you may do a return. Right? There'll be something that you will be returning. But in this case, can we do a return? And it can't be returning an int value. Okay, fine. So to understand this, fine, this aspect about methods, it's about a method, right? How can a method fail, right? Let's try to see how we fail a method. Okay, so from that point of view, we'll try to understand how the execution happens on the in Java, how execution is happening. Okay. Okay, so for that, let's see how does execution happen. So if we consider our test account class, okay, what I would like to do is I'd like to consider how the execution of the code, okay, let's assume this is a code which is written in test account, right? Okay, let's assume this kind of code is written in test account. That's inside a main method of a test account, right? How does main method execute? How Java begins its execution? Okay, so we want to look at that and then try to understand this. Okay, so if this is what is there in the main method, okay, what would Java be doing for it? Okay, and so from that point of view, let's see. Okay, so in Java, when we say Java and give a say for example, we write the I'm assuming the code for test account, and then someone says, okay, uh, Java, okay, and minus CP and other options are there, but he says, okay, I want to execute test dot test account. Okay, suppose someone is writing this. Okay, so he wants to execute test dot test account. Okay. So if you want to execute test dot test account, what will be done? First thing, it has to load the class which is test dot test account, right? And in this class, okay, it has to find if it has a main method, and when it finds a main method, it creates a array. Right? It creates an array of string, okay, and starts the execution of main method. Okay, so for that, what exactly is happening, right? So for that, what we need to understand is in Java, when an object is to be created, it has a special area known as heap. So Java, the Java virtual machine has what we call as a heap area. So it has a heap in which objects are getting created. Okay. Let's say this is my heap area. So any object would be created, allocation of object is happening in the heap. Okay, so when we say initially test.test account, yes, there is a heap area within the JVM. And then when we say test.test account, it would create an object of string array because main method requires a string array. Okay, we didn't pass any arguments, no command line arguments were passed, right? Therefore, an object of only 0 size. So there will be one object of type string array. So one object of an array of string. But this object has 0 elements. Okay, because we didn't pass any command line argument. Okay, fine. So this is allocated. Okay, so a string array is allocated. Fine, zero size string array, or whatever, depending on what command line arguments you are passing. Accordingly, a string array would be allocated, and that object is there. Okay. Next, what it has to do is, yes, for execution of the main method. Oh, I have to start the execution of main method. I need to look at all the steps which are there in the main method. So to execute the main method, it needs another kind of a structure, which we call as a runtime stack. So there is a runtime stack. Right? So a runtime stack is allocated, in which a frame is allocated for execution of a method. So there is a frame at the bottom of the runtime stack. Runtime stack is initially empty. At the bottom of the stack, we would have space for execution of the main method. Okay. So when it wants to execute a method, yes, that method has to be brought into the runtime stack. Okay. So there is a runtime stack in which the space for the method will be there. So what is the space required for the main method? It would need space for all the parameter variables, all the local variables which are part of the method. Any local variable in the method, fine, gets space here. For example, in our case, we have args. Fine, in main method we have a variable of type args. So there is space for the args variable. The type is string array. Okay, string array means it's a reference, right? And it would refer to which object? Or it would be made to refer to the, because it's a parameter, it would have a value, and this value is nothing but the string array which was allocated, whatever the size of the string array may be. Okay, I'm assuming it will be of size 0, but if you have passed some command line argument, okay, in that case, that command line argument is an object of string. So suppose someone passes a string called hello as a command line argument, right? Then there'll be the array here will say, I have one element, right? The size of the array is 1, and that would have a reference to this. Okay. So heap is the place where objects reside. All kinds of objects will be available in the heap. There are within the heap itself, there's another area, okay, as part of the heap. Okay. Fine. So there's another area which is part of the heap, and that you can think it's an extension of the heap itself. So within the heap, yes. So this is a bigger heap which I'm allocating. So there are other objects also. Okay. This area, which is again included in the heap, we call it as the method area. Okay. So you may have a method area, okay, where you recollect the class objects, object of the class, any class getting loaded, an object is allocated of type class. So objects of class type reside in this place. Okay. So for example, there is a class object for the string definition, there's a class object for the system, there's a class object for the account, there'll be a class object for current account, savings account, fine. So all such objects are allocated again within the heap, area called the method area. Okay, fine. So these are nothing but your class definitions. Okay, so various class definitions, all the classes being used, yes, the objects for the class object for them, they are in the method area. Okay, now if we begin the main method, yes, what does the main method say? Main method says, okay, I have one command line argument, so that's one parameter, so I have a space. So in the coming back to this, right, coming back to the runtime stack, in the runtime stack, one frame is allocated for the main method, right? Initially it's a main method I have to execute, or I have a frame for that. So in this, what is the space allocated? One is the parameters, so only one parameter, plus what are the local variables? Oh, we have local variable called AC1, right? We say AC1, so that's a reference variable, local variable. you might have some variable of type string, you might have some variable of type. So this is maybe AC1, this may be some, if you have said int a equal to something, or int value is there, the variable a. So you have space for all kinds of local variables. Okay. Another thing, one more thing which is information in this runtime stack as part of the frame method, right? What it says is, it is going to, now since it is executing the steps, fine, it is executing the statements which are in the main method. So in this frame, it will also keep track of, oh, I'm currently at particular line. So there is something called a line number. Okay. Line number of the method which it is currently executing. In this main method, I'm currently executing a particular line. So this will keep on getting updated as it is progressing line by line within the main method. Okay. So there is one information. So the information, what is allocated in a frame for a method on the runtime stack? Space for parameter variables. These parameter variables would be getting initialized because someone is invoking that method. Okay, fine. Okay, so for example, in our case of main method, the args is a parameter variable. So that args parameter variable, this is args here. Okay, the args parameter variable is referring to the string array object which was allocated in the heap. Okay. Fine. We have AC1 as a reference variable. Let's consider this AC1 is a reference variable. So this is a local variable, right? It's not a parameter variable. So it will have, see, these local variables would not have any initial value. Right? So when someone executes the code, let's assume the execution of code which is saying AC equals new, okay, and maybe you said new current account, okay. Okay, so you create new current account, passing parameters. Yeah, you are now passing parameters to it, right? So you have parameters which are, so these parameters are saying, okay, there's a name and there's some initial value, there's a long value, or maybe in this case, it might be simply a int, that's also fine. So suppose someone is executing this code from the main method. So if it is at this line, what does it mean? AC equals this. Oh, we have the variable AC, that's fine. So there is a space for AC, but now it says, I want this new current account object to be created. Okay. So it would have, fine. So what would it be doing is, it would have to invoke the constructor of current account. Fine. It locates the current account class definition. Fine. It would locate the class definition for the current account and would know, yes, we have a method we have a constructor with 2 parameters, and that I need to execute, right? So it would now know from this that there are these, it would now, since it has to, so from main method is asking it to execute a constructor. Okay, so when it is being asked to execute the constructor, it has to execute constructor. So the constructor, there would be another frame to be allocated because a constructor is to be executed. So we have a frame for the constructor. This frame below is for main, but the one above it is for the constructor with 2 parameters. Okay, so this is for the constructor. Okay, fine. So there is a frame for the constructor which has to be allocated on top of the main method. See, the main method says I'm at the line where it is calling the constructor. Okay, so main method is actually getting frozen. Okay, maybe it is at line 1 where I've, sorry, it may be line number 5, right? So initial lines are import and those kind of statements. So some particular line says, oh, I have to execute the constructor. I have to call the constructor. AC1 equals new, and it is calling constructor. So when it is calling the constructor, with 2 parameters, the constructor for 2 parameters, a frame needs to be allocated. I need to first finish that, then I can proceed to the next line, which is maybe line number 6. So line number 5, I'm assuming this is line number 5. Okay, so line 5 is for AC equals new current account. Okay, so when it is executing line number 5, okay, in order to execute line number 5, the requirement is to execute the constructor. Okay, because it has got new current account. So it says, okay, I'll to finish this, I'll have to allocate space for the okay, this is a constructor with 2 parameters, right? So I will have 2 parameter variables, one for the name and another for the long, which is the balance. Okay, so balance field says, okay, this is the value for the balance, but the name, oh, there is an object. See, this is a string object. So there is a string object which has the value James. Okay, and this starts referring here. Okay, this is the initialization when the constructor is called. You're saying new current account. Okay, fine. This current account constructor, so it has to now execute the current account constructor with 2 parameters. But what does it do? Right? It says, oh, I am at line number. So within the account.java file. See, this is line number is from the Java file. You can see this line is from test account.java. Line number 5 is test account.java. But now this is a different frame which is referring to constructor of account class. So this is from account.java that the code is picked up. Okay, it is the account.java whose code is available as the second frame. Fine. Or you can say this is the bottommost frame is for main. Above that is the main frame for current account constructor, because we said new current account, right? So new current account, 2 parameters. Okay, fine. Those 2 parameters are initialized and it will keep track of the line number. The first line within that method. So it's not line number 1 here. The line number is the line of the Java file. In account, sorry, this will be current account, not account.java. This is current account.java. This is saying current account.java file. Okay. In the current account.java, because you are saying new current account, right? In the current account.java file, fine, there is a line number which says, okay, I am at line number. I have the statement for which is within the current account constructor. So in current account constructor, what is it doing? What's the statement in the current account constructor? The statement in the current account constructor is saying, so I'll just keep writing here. First was new, this, okay, this is from, so this is the execution which is from test account. Next one, this statement is from test account, but then it goes to the constructor. When it is going to the constructor, it is from current account.java that the line will be there. Okay, you're calling current account constructor. So in current account.java, there is this current account constructor, and in this current account constructor, the line which is used is, it is saying super. Fine. And calling the constructor of the account class, right? It is just simply passing on the name and the, so the variables, find the local variables for name and the balance, opening balance, they are available here in the frame. Okay, they have been initialized, and that is again being used for calling the constructor of superclass. So that means it now needs to execute the constructor of superclass. So this one, which is from current account constructor with 2 parameters, the invocation will be frozen. I can't proceed further. So maybe the super is appearing at line number 10 within the Java file in current account.java. Then this says I'm at line number 10. Okay, so bottommost frame says this is main method. I'm at line number 5, calling the constructor of current account. Current account constructor says, oh, I am at line number 10, which is actually within the it is within the current account.java file that you have used super. So when it has used super, it has to again allocate the frame for another frame which is corresponding to the constructor with two parameters of the account class, right? It has to say super. Super means the account class. So this frame refers to account.java. And it has again two parameters. It has received those two parameters. So let's assume the two parameters are there, one for the name, other for the opening balance. So they would anyway, because of the invocation, those values are getting copied, right? And this would still be referring to the same. So there is a name variable for the parameter variable for the name, which is getting initialized. But remember, this frame is for account. Account constructor with two parameters. That's what this is for. Okay, fine. It would know that I am currently at so and so line within the constructor. Okay, so if it now has to refer to that account.java file. Okay, which line it is at. Okay, and then fine. Once this initialization is done, what is it doing? If you look at the line in the account.java file, okay, where it is calling the constructor of account with two parameters, from that constructor with two parameters, it is invoking the constructor with three parameters. So this is account with two parameters, this is account constructor with three parameters. So account constructor with three parameters, yes, it is going to receive those three values: account number, name, and balance, opening balance. Opening balance is getting copied, name is getting copied. Okay, so name would refer to the same object. Okay, fine. And oh, that last account number, where is the last account number? Because we have said plus last account number. So where will it be? Oh, we have the class object for the account class. So there is a class object for the account class in the method area where the static variable would be allocated. So this value, so this is where the last account number is. This value will be getting incremented and then used to initialize here. So this is getting an initial value. Okay, so the constructor with three parameter, right? It enters the constructor with three parameters and it has a line number. Okay, the line number corresponding to where the constructor is there. Oh, there are three statements in this constructor. See, one more thing which we haven't seen in all of these in the entire runtime stack. Okay, one thing which is actually a parameter, but we forgot to use it here. Okay, in the main method, that parameter is not there. But when we call the constructor with three parameters, with two parameters, there actually are three parameters. And the very first parameter in any constructor or a method, of course, the method not being a static, is nothing but the parameter called, recollect this. This is a receiving parameter. Okay, because you have said new current account, allocation would have taken place for the current account object. It has space for the three variables. But understand, the three things are actually part of the account definition: account number, name, and balance. Space has already been allocated for it. Okay, that this is again initializing the this for the constructor with two parameters, and that in turn is again having this variable. So when we say constructor with three parameters, actually there are four. Instead of three, there is four. The fourth one being, the very first one being called as this. Recollect, we have a receiving parameter for this. Okay. So this is nothing but it is referring to the object which is allocated already. So this is allocated, fine. And now if you look at it, right? So there is, I have a reference to the, so this is being referred from here. Okay, fine. And then plus plus last account number, the initialization for this is done, right? So we have said, okay, account number is received here, and this account number, it says this dot account number. So this is referring to that object. The object has account number field. So this dot account number to be copied from the parameter which we have received. Fine. Same way, this dot name was a reference to the string variable. So this reference, right, the reference which is over here, okay, this is copied into the reference here. So this is nothing but your allocation of the current account object. It is receiving the, it is getting reference to the name. You have the opening balance which has come into your frame. So this dot balance is nothing but in the account object over here, and that gets copied from your parameter variable. Right? So the initialization of the account object is done. Okay, the constructor of account with 3 parameters finishes. Fine. What it has done? This dot account number equal to the parameter account number, this dot name equal to the parameter, the second parameter, this dot balance equal to opening balance. So that is making initialization in my heap area, right? Because this dot something, okay, that means on an object. Okay, but once this code is finished, right, if you look at the runtime stack, what has happened? Is there a need for this? The topmost frame which is in the runtime stack has done its job, right? And when that has done its job, okay, it has to be removed from the top, right? So this one says, okay, my method execution is over, and this which is on the top will actually get removed. Let me see if it's working. Okay, so this gets removed. Okay, the topmost frame will be removed, right? And then it will try to, so the control now goes back to the constructor with 2 parameters in the account class. But in the constructor with 2 parameter also, after it had said this, there was no other statement. There was only one statement. So as far as this particular frame is concerned, this frame also will also get removed from here. Okay. So the frame gets removed one by one. Okay. And then it comes to the constructor of current account. So constructor of current account with 2 parameter, that also doesn't have any further statement. Okay, so if it was there, it would have to execute that. Okay, and therefore this also gets removed. So the frames get removed, but they have made the changes in the heap area. And the object which was to be updated, that object has been updated. Okay, and then we have said AC equal to that particular object. So whatever is, when the constructor finishes, okay, the AC equal to, that is now to execute. The constructor part is over, but AC, my local variable, right? So I have space AC1, sorry, this is AC1. This local variable has now got to refer to the account object which got initialized using the constructor. Okay, fine. So account object getting a reference variable equal to and a constructor. So constructor, yes, it calls a superclass constructor. Superclass constructor in turn, again, if it had any other superclass, it would have called that constructor. Okay. So what we are having is on the heap, as the execution, as the invocation happens, right? Okay, it would be doing the, it would be populate, it would bring up a frame for the execution of that constructor or the method. Okay. Okay, let's just assume if someone is calling AC1, sorry, AC1, let me put it, AC1 dot withdraw. So someone says AC1 dot withdraw and some amount has been passed. So if that's the next statement, right? First statement was to create an object. Second statement, let's assume, is the calling the withdraw method on a current account object. So if you look at the code for constructor, okay, I think I'll show it, I'll scroll so that it becomes more clear. I think I'll put it again, right? Okay, I'll put it, the heap and this area again so that you can, so just look at this. Okay, so that's the runtime stack, and maybe bigger, and we'll have a bigger place for the heap area. So we assume there is a heap here. Fine. Space for the main method. Okay, so okay, what does main need? Main has only one parameter variable, that's okay. It has already got, I'm assuming it has got AC1. This is AC1. This is your args. Okay, and somewhere there is a line number also being managed. Okay, fine. Here, what I'm assuming here is that first statement is already executed. So we have in the when it called the constructor, line was AC1 equals new current account. So if that has already finished, it would have actually resulted in a object of current account. Okay, since it is having the instance variable from the superclass. Okay, account number, some value for the account number is there. Okay, some value is there. Fine. There is a name which is a string type, so it's a reference referring to a string object which contained James. Okay. So there is a reference to this, and again the balance field is initialized with some value here. Okay, whatever was passed as the opening balance. Okay, and AC1 is referring to this object. Okay, this is what would have happened. And this is the result of our first statement. Okay, when I'm only showing the relevant things, when no other things are being shown. So this is my variable for AC1. This is AC1. Okay, fine. Now the next step is, so I'll only show withdraw method now. So someone is saying AC1 dot withdraw, and he passes a value, maybe 40,000. Okay, so if someone calls AC1 dot withdraw, right, what would happen? Oh, this withdraw method, which withdraw method will be used? It says AC1 dot withdraw. What is there in AC1? An object of which type? Current account. It's an object of current account. So withdraw method according to current account will be brought into the next frame here. Okay, so this frame here is corresponding to the withdraw method. Withdraw from current account. Okay, it has only one parameter which is for the amount. So yes, it is receiving the value of amount here. Okay, but one more important thing for all the non-static methods is there is a receiving parameter called this. Okay, where it gets to know on which object the withdraw method is called. So it has a reference to that same object of current account. So this is how the picture would be. Okay, initialization of that 40,000 in the, so that's a place for, so this is a frame where it has withdraw method with in the current account. So withdraw method in current account says, okay, I receive an amount. So there is an amount field and it has got this. Okay, this is nothing but the object on which the method withdraw method is called. And withdraw method says only one parameter, but that method on an object of a current account. So that's my current account object. Okay, so this withdraw method is the withdraw method of the current account. Okay, fine. What is the code in the withdraw method of current account? So if you look at that code, it says if and not, okay, if not super dot withdraw. And the parameter, it says if not super dot withdraw. What is the parameter? Whatever is the amount given to me, oh, I'm passing that same amount to the super dot withdraw. Okay, fine. In that case, yes, I will return a false here. Okay, see, this is the kind of code which is there in the withdraw method, which is over here. Okay, so if it has to say, so what's the line saying? If not super dot withdraw. Oh, this is super dot withdraw. Again an invocation. So you're saying super dot withdraw. Oh, super dot withdraw means I need to invoke withdraw method as available in the super class. So this withdraw is from current account. Okay. And on top of it, a withdraw method from the account class. So this is for withdraw method from the super class. Okay. So what is allocated here? It has amount as amount field. Fine. Amount is a parameter variable where again the same value will be getting copied. Okay, 40,000. And it also has a this. This is nothing but the object on which it is getting invoked. So this is also referring to the same object. Okay. And then it says if not super dot withdraw. Yeah. So this super dot withdraw results in this, right? So it has a, so in the frame which is over here, it is still stuck for finishing the super dot withdraw. Okay, fine. So line number would be pointing to where it is at currently at. I'm executing super dot withdraw. So this is having line number according to super dot withdraw. And then in the super dot withdraw, yes, it would also have the line number. What does the line number say? Oh, that line which is in the account.java now, right? It's in the account.java. The withdraw method of account.java says if if amount, yeah, fine. If amount is greater than this dot balance, in that case return false. Otherwise, update the balance and return true. Fine, that's the code. Okay. Fine. So when it has to execute this code, okay, fine. How will it be doing this? If amount is greater than this dot balance, right? So it comes and executes. So in the topmost frame, which is for withdraw method of the account class now, okay, it would just be looking at amount is greater than, is this amount greater than this dot balance, or this dot balance is over here. So my balance here is maybe 1 lakh, right? And is it greater than, so is 40,000 greater than this? So it says no. So it won't execute that return statement, but then it has to go and, so the next step would have been, so here the line number would be getting updated, okay? So it would update this line number and as it follows each step in the, so it would remain in the withdraw method with the of the account class, okay? Execute the next step. The next step says, okay, update the balance. This dot balance minus equal to amount. So from this dot balance, which is 1 lakh, deduct whatever is the value in the amount, right? So it executes, updates this object of, the object which was given to it is getting updated, right? Okay, and then it says return true, right? It says return true. So this method now finishes, okay? This withdraw method now finishes, and that would result in removal of the withdraw method. But now let's look at this one thing. The aspect which we are trying to now, which I want to bring out here is, it is a return statement which is executed for it to finish and go back to the frame which is below. See how execution happens. You have a method, main method, invokes another method, that method in turn invokes a new method, and it may in turn be invoking another method. If it is the invocation going on further and further, yes, it will bring up new and new frames according to the invocation sequence. As a particular method finishes, that particular frame gets over and it comes back to the lower frame. Okay, the topmost frame is the active frame. Below it is just waiting for the frame which is above it to get over. So if this frame gets over, then it can proceed further. Okay, so that's how the execution is happening, right? Now one thing here, fine, one frame for one method. Look at this frame. How does a frame finish? A frame would finish by a return statement. And there is a return because of which the frame is getting over. Right? See, even with methods where return type is void, okay, when you have not written a return statement, you can assume there is a return right at the end. So when the method is over, there is actually a return statement there. Okay, so you can always assume, even for methods which have return type of void, that there is a return statement. So return statement is nothing but finishing a method. And we understand return statement is finishing a method. It is used for, someone who is waiting for a value to get the value if there is a return type other than void. If the return type is void, it is just waiting for that thing to get over and say, okay, I have finished. Okay, so when a return is executed, we say the frame here has completed successfully. A frame finishes successfully. And what is the other thing which can happen? Any task you take up, there are two possibilities about the end result. You get a result from it which is successful, so your task has completed successfully, or the other thing is your task has failed, your operation has failed. Right? Similar to, oh, someone tries a deposit, right, and gives a negative value. What should happen? Should it be successful or should we fail it? Okay. And the idea would be, should a method be successful if someone gives me a negative? Should the withdraw or a deposit method be successful if someone is giving me a negative value? What should happen? Should it be successful or should it be failing? A negative value for amount to be deposited or withdrawn? What do we do with it? Should we go ahead and just make the deposit, or should we say no? This is not completing. This is not a successful finishing. I don't do a withdrawal. I don't do a deposit here. So you can indicate that this is going to fail. Okay, a particular frame can fail. So how does a frame finish? Two ways. One is return indicating success, and another statement which is opposite of return is a statement called throw. And what do we throw? When we say return, there is an expression which matches the return type of the method. And when we say throw, we have this new statement called throw. Throw is used for failing. Throw means if a throw is executed in a method, it means that method has failed. So if you want to fail a method, we'll just have to say throw. But throw followed by what we call as an exception. Throw has to be given an exception. Okay. Yeah, any questions here? Yeah. Is the idea of the runtime stack getting clear for the purpose of execution?
Yes, I have one question.
Yeah.
Let us say we are using some JDK methods. So
Okay.
let's say for account or deposit or something, we are using some string class methods.
Okay.
How those classes gets loaded?
Oh, every class which is used is loaded. So even the JDK classes, they are also getting loaded in the heap.
Okay.
So their definition is there, right? For example, you are using the length method on string. Okay. So you are examining the length of the name maybe. If length is greater than 25, right? Maybe I don't want, I would like to truncate or whatever, right? So if you, when you say string dot length, what happens? Yes, the length method of the string.java file is brought into the runtime stack. It will be part of the runtime stack. Any execution is always through the runtime stack. You are invoking something, okay, I have a space for that. I have to allocate a frame, execute it. So yes, there is, and so even if it's a JDK method or anything, right? Only thing where you still always have a frame being created, but that frame will not be part of the JVM. Okay, that frame actually takes you out of the JVM only in one case. That is the case where you have a native method. Okay, if there is a native method, that means it's a code which is not in Java. So in that case, yes, of course. So from this frame, it would actually be calling and going out of the JVM area. Okay. Otherwise, yes, anything you are calling, it's any other. So of course, there are lot many low level things which have been done from the JDK API, okay, Java library classes. And so there is possibility of some native methods being invoked in such cases. So those may not exactly, but each one, a frame is definitely allocated. Even if it's a native method, a frame would be allocated, but then it would, in this native method, yes, not in this frame, nothing much, there's not much information, okay. from here it is actually taking you out of the JVM area. Okay. Fine.
Yes.
Okay. So any execution always from the runtime stack. All execution happens from the runtime stack, and runtime stack is nothing but as you are invoking anything, it's like, oh, I'm doing this operation, but this operation in turn needs another operation. Fine. I need to finish another operation. See, look at it in another way. Look at this whole runtime stack in a different manner. Fine. Let's see. Uh, you are given a task of finishing the main method. That means you take the slip, okay, which has the code for the main method. Look at it, okay, and then go to the first step. Oh, this step says I need to use another. I need to call the constructor. Okay. Oh, I need to call the constructor. Let me go into the definition of that particular class constructor. Keep it on top of this. You keep your mark, that is, you remember the line number. So you are keeping your marker on the, oh, I'm currently at this particular statement, right? And then you don't proceed further in that particular slip. Fine. You bring the slip which is containing the code for the other whatever you are invoking from the earlier earlier frame, right? So first is a whole whatever your first is the main method. That main in turn says, okay, I want to call that method. Okay, fine, bring the code for that method on top of it. I'll remember I'm at this line here. Okay, this is the line for executing the method which I'm currently calling. That method in turn may be using some other things. So as it uses something, oh, it will have to bring the code for that on top of it. And unless that top thing finishes, it can't go and proceed further. Okay. So always in the runtime stack, there is a topmost frame which is active. Okay. The ones which are below that are waiting for the completion of the one which is above it. Okay. So fine. So once this withdraw method finishes, then it can go forward in the main method. Okay. But so now we are talking about what happens with each and every frame. How does a frame finish? So frame finishes because of a return method, because of the return statement. Return statement, see, each frame is expected to return a value according to its return type. Each frame corresponds to a method. That's one thing. And each method has declared its return type. So the one who is invoking the method knows what kind of value it will give me. Okay. Right. Say if we would say Boolean, fine, we might say Boolean status equal to AC1.withdraw. Okay, because it's going to return a Boolean value. I'm waiting for a Boolean value to come out of the withdraw method. Okay, but it can say, no, I don't want to give you a value here. You have given me a negative value for the amount, and therefore I want to say this has failed. Okay, so you can fail a method by using a throw statement. So this is what is throw. Throw and return. Throw represents, throw is for failing, return is for giving a successfully finishing it off. So I am successful in getting a value. Okay, therefore I am returning. Returning is nothing but indication of successful completion. Fine. When I say, look at A divided by B as a method, right? If it's a method, okay, it is returning a value to me. Okay, but in case B is the second parameter is a 0, okay, I will just give you an error. So I'm going to throw something. Okay, so errors are always thrown. Errors are nothing but your exceptions. Okay, and we are familiar with the return statement, but now we have to be familiar with the throw statement. Okay, fine. We know about the return statement. So let's look at the throw now. Okay, I'll keep this and maybe I'll put in the text. And any more questions? Yeah. Anyone else has questions on the runtime stack and the heap, how the execution happens? Okay, fine. Then I'll proceed. So one more thing here. So we are now trying to look at what is this throw statement. Okay, fine. Familiar with the return, and therefore let's look at throw. Okay. Okay. See, you are having maybe any method. Maybe there is a method M1. Return type is, so maybe return type. I'm just keeping it as void. Okay. Okay. You have some statement invoking method M2. You're calling method M2. Fine. And if M2 will finish, I will have some simple assignment statements, and then maybe I'm calling M3 another method also. Okay. Then this is some kind of a coding which is there, right? Okay. Now one thing here, I have in my step invoked a method. Okay. M1 has invoked M2. There are two possibilities with M2. Either it has used a return statement to come out, and what is the other way to come out? It might have used a throw. You either use a return or a throw, which is what is finally done from the method which I have called, right? So there is a frame on top of which the frame which is currently active, okay, that says, oh, I am returning a value. Then what happens? If M2 returns a value, if it returns successfully, I will be proceeding to the next step. What happens in case M2 says I have failed? Should it be proceeding to the next step? Or failure of M2 is the failure of M1? M2 is successful. Oh, my first step is, I've succeeded in my first step. Let me try the step number 2. Okay, fine. I can proceed with the next step. Step 2 is successful. Okay, I'll go and proceed to the next step. Step 3. Step 3 says, oh, this is a failure. Will I be proceeding to step 4? No. Fine, I won't be proceeding to step 4, but I'll say, oh, I have failed. This is my failure. One of my steps has failed. That means this is my failure also. Okay, so this is the normal convention used with exceptions. And the normal flow is going to be like this. Here, what is the flow? Try to execute a statement. If that statement is successful, proceed to the next statement. Try to finish that statement. Each statement has to be successful in a method for the method to be successful. And each of the steps in the method must successfully finish. Right? And then at any point, I can say, you can finish at any point in the method by using a return. Okay. At any point, you can use a throw and say, I want to fail it. But another way of a failure is not only just by saying explicit throw, but I used a method M3 and my M3 method maybe this has used a throw to come out. That means M3 was not successful. If M3 has resulted in a throw, the throw immediately gets propagated. That means it's not going to proceed further, but it implies that M1 has resulted in a throw. M1 is using M3, M3 results in a throw, that one M1 is also having a throw. It's as good as that. Clear the difference between how a return is dealt with and how a throw is dealt with. Okay, I'll just show. It's something like this. This is runtime stack. Okay, this is main calling M1, and let's say this is calling M2, and if M2 says throw, if M2 see whatever fine, from M1 there is a place where I said I want to do M2. If M2 uses a return, he will proceed further. If M2 uses a throw, it will throw, because the place from where I have called M1, okay, because of which this frame has come, okay, that also results in a throw and it comes out. Okay, so throw at any point would just simply result in the entire runtime stack getting cleared up. The runtime stack will just come out. So main method finishes, of course, with a failure. A throw from M2 results in throw from M1, that results in the throw from main. This is a default behavior for a throw. Throw is nothing but your exception. We'll see the meaning of exception. We'll also still have to look at the syntax for throw. Okay, fine. So clear, return and throw the difference. If it's a return, I proceed to the next step. If it's a throw, I'll throw. Right? So we go with this premise initially. Okay, then we'll see. There are mechanisms by which, because I was executing something, I knew that this could fail, and I was prepared for handling the failure condition. So you can write code to be prepared for if it fails, then what I'm going to do. Okay, fine. That will be where we call it as exception handling. How do you handle an exception condition? So all that will come. But before that, a very basic thing related to methods. Right? It's not only, when I say method, even constructors are to be treated like methods. So if you look at that aspect of, okay, what's the syntax? Let's see, what is the syntax for a method or a constructor? What's the syntax for a method? We'll discuss it with methods, but a similar thing. Okay. Okay, let's see here. Okay, we look at syntax for a method. Yeah, what is the syntax? We said modifiers. Okay, that's fine. After modifiers, what's the next thing after the modifiers? Okay, if we consider the generic discussion, a method may have a type parameter list. Okay, and then comes the return type. Fine. After the return type comes the method name. And after the method name comes, what's the next thing? parameter list. Okay, what parameter it takes, and after that comes, okay, we haven't actually I didn't put the what is the optional part. What are the optional things in this? Okay, modifiers are all optional. Type parameter is again optional. Okay, only for generic methods it would be there. We have return type, which is mandatory. We have method name, which is mandatory. Okay. Okay. I think what I can do is I can start following. I just put the whole thing in a single line. Okay, vertical line, vertically. So we know each of those things, right? Okay, return type, we have method name followed by parameter list. So, and this is, okay, this is optional. Okay, this is optional, this is mandatory. Let's align that. Yeah. After this, another optional thing which is available is the there is an optional part which is the throws declaration. Okay, and then the following thing after this would be, depending on the modifier, you might put a semicolon, or there might be a, so it might either be a semicolon or there might be a method body. Okay, okay, so one of the two things. Yeah, when I put in braces, you would say it's one of them, right? So either a semicolon or it might be a method body. Okay. And method body is nothing but it comes in braces. Okay, so if you look at it carefully, this one, there are two important things for a method. One is return type. What is it? Type of value on successful completion. Okay, so if it is successful, what is the type of value? And what is this? Throws declaration, type of exception, or I'll say type of failures. Okay, it's nothing but a list. Basically, the throws declaration is nothing but a list of exceptions. Okay, so there is the type for the success, there is the type for the failure. Okay, a simple example would be something like this. Public, so it's a modifier. Return type is int. Name of the method is divide. Right? Takes parameters int a, comma int b, and I'll say it has a throws. Okay, there's only one here. Okay, then other thing, yeah, of course, there might be a body or whatever it may be, right? So you may have some body. In this body, yeah, it would say if b is 0, then a throw new okay, yeah, it is something like this. You can see we are using a throw which matches the throws. We are using a return whose expression matches the return type. So method has, in a method you indicate both the things. If it will be successful, you will get an integer value. If it is not successful, this is what can be expected. You can expect it to be giving an error of this type. Syntax for throw. What is the syntax for throw? What is the syntax for return? What's the syntax for return? The keyword return followed by optionally, okay, I'll put it optionally, expression. Okay, and that's the syntax for return. What's the syntax for throw? The throw, so keyword throw followed by, it's not optional, it has to be there. It is a, we say it has to be some kind of an exception. Exception object. It can't be null, and you can't be throwing a null here. Okay. And so throw is always having some kind of an exception. Okay. So yeah. So what are exceptions in Java? Because I've said, oh, exception object. What are exceptions in Java? So what is exception? An exception in Java is, yeah, what is it? If I say instance, it means object, okay? It is an instance of throwable or any what is throwable? It's name of a class. See, following a throw, what can be given? Anything which is throwable. So when I say exception object is nothing but object of a type throwable. Okay. Okay. So we got a class called throwable. Right? So throwable represents all kinds of error conditions basically. Exception is nothing but a error condition. Okay. There is a class hierarchy for the throwable class. So yes, object class is the super class for throwable, but under throwable class, let me put the subclasses. So under the throwable class, the subclasses are as follows. You have a subclass called exception. There is another subclass called error. Okay, I think I'll put the error first and then I'll put exception. Okay, so we have a class called error and there's a class called exception, and under the under the exception class there is also another subclass called runtime exception. So throwable class has two direct subclasses. One is error and another subclass is exception. Exception class has one of the subclasses as runtime exception. Okay, fine. Now one more thing I must mention here is there are other subclasses as well. Okay, there are many other subclasses, but for us, yes, this is the important subclass. Okay, which is important in the concepts related to exceptions. Okay. Okay, there are other subclasses here. Okay, error also has its own other subclasses. There are subclasses of error, there are subclasses of exceptions, but one of the subclasses is runtime exception, and it in turn has other exceptions. Okay, so there are subclasses of, so everywhere you will find subclasses, but under throwable only these two things, right? We don't have any other thing under throwable, directly under throwable. So everything is either under error or it is under exception. And within exception, again, one of the class is runtime exception, and then we have lot many things under the runtime exception as well. Okay. See, why I have shown this is for the next concept. Okay. Okay. In Java, we have concept of checked and so we have two kinds of exceptions. Okay, I think you will clearly understand the difference between. Okay, I would like you to know what is the difference between exception and exception. Okay. Yeah. What's the difference between these two? That capital exception, this one is same as this one. Okay, so we are looking at the class name actually. Basically, when I use capital E, we are looking at a class name. So there is a class which is a exception, capital E is a subclass of the throwable class, right? Whereas when I'm talking about exception, yes, we are looking at exception in Java, which is mentioned here. Okay, so clear. So the word exception, yes, we have to understand whether we are looking at the concept of exception, which is nothing but it represents all kinds of error conditions. All kinds of error conditions are represented by exception. So exception is nothing but your throwable, right? Conceptually, okay. So a throw statement can be using anything which is throwable or a subclass of throwable. So this is for throw, okay. Entire thing which you can use with throw is this, right? Yeah. So if someone says throw and says new rectangle, okay, that's going to be an error, right? Because the rectangle is not throwable. Right? But if someone says throw new and he says exception, right, and gives a message, something like this. This is valid, okay, because arithmetic exception basically is here. Okay, I'll put it. Okay. One of those subclasses is the okay. Here. It's a subclass of runtime exception. Okay, it's coming under the runtime exception. Okay, class hierarchy is like this. So capital E exception is nothing but our class called exception. Right? And when we say exception, yes, we are talking about all throwables. Okay, this exception represents all throwables. Okay, now coming to two types of exceptions in Java. Okay, we call them as checked exceptions. So we have checked and unchecked exceptions. Okay. All exceptions in Java are checked except for subclasses of error and runtime exception. Okay, so this is one thing. We need to differentiate between checked and unchecked exceptions. Okay. Yeah. So okay, I'll just show this class hierarchy in the diagram form, and there will indicate what is checked and what is unchecked. Okay. So what is it? Fine. So the class hierarchy is, what's the class hierarchy we have? We have a class called Throwable. We have a subclass called, so one of the subclass of Throwable is error. Another subclass is the class called exception, and then we have a subclass of exception called the runtime exception. And so that's the way we have, right? There's a class called so Throwable. This represents all kind of exceptions. And which are the checked and unchecked exceptions? What are unchecked exceptions in this? Anything which is under error, these are all unchecked, and anything which is here is unchecked. Okay, if there is anything under, someone creates a subclass directly in the Throwable, that's going to be checked. If someone creates a subclass under exception, other but not on, which is not under runtime exception, that's a checked one. Okay, fine. Anything here is checked. Okay, anything here is checked. Okay, this is all unchecked. This is all unchecked. Fine, clear? Exceptions means object of Throwable or object of any subclass of Throwable is a exception. We have a class by the name exception also, E capital, right? So that's name of a class also. Fine, so clear on this? Okay, so what's the difference between checked and unchecked? One is we know how to identify what is checked or unchecked, right? But if you want to know what is the difference between checked and unchecked, okay, I'll put it in the text here. Okay, yeah. So throws is compulsory. Throws declaration, right? You know, this is throws declaration is compulsory for checked exceptions. Okay, throws declaration is compulsory for checked exceptions. Okay, so if I fine, so yeah, so now if I go back here, I had written something, right? I was writing a yeah. Where did I write it? Yeah, here. See, if I look at this, I had written the small method code for divide. Yeah, here divide. Yeah. Okay. So you can see here throws. I've written throws arithmetic exception. So it is fine, right? Because what I'm indicating is if you try to execute divide, you be aware you may get a arithmetic exception. That's what I'm indicating with throws. Okay, but this is actually not compulsory. Even if I don't write, it is fine. Okay, so instead of this, suppose I had just finished here like this, this was also fine. Okay, if I didn't put the throws arithmetic exception, then also this is correct. Okay, fine, there's no problem. Okay, let me write another code for it, okay, to indicate the difference between checked and unchecked, right, from the usage point of view. So instead of divide, let me have a method. Maybe it returns a byte array, and the method is called read method, and read method is taking as parameter. So this just string for the file name. Okay, and I'll say it throws, instead of arithmetic exception, I'll say it is throwing a IO exception. Okay, now that IO exception is actually it's a subclass of exception, but not under the runtime exception, which means it becomes a checked exception. Okay, and there, of course, the code is going to be different. Okay, and then it says if, okay, so there is some code to find out if the file does not exist. Okay, and it says throw new file not found exception, and gives a message. Okay, some message will be there. Okay. So it's using the concept of file not found exception here. Okay, so now tell me, yeah, is this okay? One thing, this throws IO exception is compulsory, right? This is mandatory or not. I could have written it even as, okay, one thing, oh, you find a mismatch, right? What is being thrown is file not found exception, but what I have written here is throws IO exception. And the reason for this to work here is that file not found exception is actually a subclass of the IO exception. IO exception, one of the subclasses is file not found exception. Okay, so I'm just taking care of only one condition here, which is related to if file is not found. But there could be other conditions also. If there is some problem at some other place, there might be. So if some other file, unreadable file exists but unreadable, right? Okay, if unreadable, it might be saying throw new IO exception, or maybe some other subclass of the IO exception. Okay, maybe something like this. Okay, but one thing here, though in the difference between the two you can see here is, in the divide method I'm throwing an exception called arithmetic exception. That's a throw statement. In read method also there is, I'm saying throw IO exception. Okay, at some place I'm saying throw new IO exception. Right? In case of read, it is a must that I put a throws declaration for IO exception. Whereas in case of divide, it is not a must. I may skip this part and that is still working for me. Okay, this is still going to compile. Whereas, so the difference here is, because what is being thrown from inside this method is a checked exception, you need to mention it. What is being thrown from inside this divide is an unchecked exception. What is being thrown? It is throwing an arithmetic exception, which is an unchecked type, and therefore it is not mandatory here. You may, if you want, you can always put it, but it's not compulsory. Okay, so checked exception throws is compulsory. Okay, in other words, so let me now write it in words. In any method, we cannot use a statement which can result in a checked exception being thrown a checked exception being thrown which is not covered by the throws declaration. So you can't have a, so this is what is the basic requirement for a method to compile. If in a method there is any statement which may result in a checked exception, but that's not being mentioned in the throws, then that method will not compile. Okay, that's how the checked exception is compulsory. So difference is only this: checked is compulsory for, sorry, throws is compulsory for checked exception. Okay, fine, clear on this difference between checked and unchecked? Okay, fine. I think yeah, we will have to continue tomorrow. Okay, but just try to look at this, and I think you can read the chapter in the book also. And I think I already shared the book, right? So there is this chapter on exceptions. I think chapter 12. Okay, fine. Any questions are there? Yeah. Yeah, any questions?